Hi, everybody. How's it going? My name is Carl Diaz. I'm with the Learning Resources Center here at the University of Colorado, Denver. And today we're going to be talking about superposition of forces, or essentially net force. I just, after working with a lot of students, just kind of realized maybe we should have a video like this. I think we assume that you kind of understand, and it's complicated, so I don't know why we assume it. But I think we kind of assume that when we net forces, or when you think of net force on an object, that you know that we are using this principle, superposition of forces, or essentially. And I think, a lot of students get the idea down by the middle, towards the end of the semester, but you should have it down at the, in the beginning, not towards the end, because you're doing this the whole semester. So superposition of forces, what does it mean? Well, the fundamentals of it is right in front of you. It says when one or more forces, right? When one or more forces are applied at a point on a body, they have the same effect as a single force equal to a vector sum forces applied at the same point. Okay, so essentially, I got a few examples down here, and then we'll do another one. But right, for this first one, right, we have all these forces. They're all equal and opposite. So the superposition, or essentially if we wanted to look at all because, when we apply these forces, they're all being applied like right at that center spot. I probably should have connected those, right? And so there's a superposition at that point of all those forces, which means essentially there's a net force that exists, or there's only one, and that's what this up here, this equal to the vector sum forces. Or vector sum force is what that should say, not force is, because it's one vector. So essentially what that superposition of forces is saying is that you could have a bunch of force vectors applied at one point, and you should be able to take all those force vectors and turn them into just one vector that's going to equal the magnitude of all those vectors just summed together. Okay, and that's what we're doing for net force. Whether we get net force is 0 or whether we get some value for net force, either way, we're using the idea of superposition of forces. We're looking at all the forces at one point, or all the forces applied to one body or object, and then we're trying to turn all those different forces into one force vector every time we net a force. Okay, so that's what you need to keep in your head. Okay, even though there's multiple forces on an object, when we're netting them, our goal is to use superposition of forces, or essentially try to turn all those vectors that are applied to the object into just one net vector. And sometimes there isn't one, right? So for this first example, like I was saying, right, we have all these vectors, right? We have the ones pointing opposite of themselves in if you want to call that the y direction, right, up and down, and then to the left and right, we call that the x direction if you wanted to. We have two vectors, but the vectors in the x direction, even though they're opposite, they're the same length. The vectors in the y direction, even though they're opposite, they're the same length. Right? So if I were to do the superposition, try to, draw a picture of all those forces as one force vector, well, it would look like the picture I have here. There's nothing to draw. All those forces, and you don't want to use the word cancel out, but the forces balance themselves out. So if they're balancing themselves out, there's essentially no net force that's going to be there. So the force vector for all those vectors, there isn't one. One doesn't exist. A superposition of a force vector, this one vector that can be used to describe all these vectors at once, doesn't exist, because all those vectors essentially equal 0. Okay, if I were to look, if you're not understanding what that means, right, let's just imagine that let's do that in a second. Let's do that. Let's finish these examples, then we'll do that in a second. We'll do one more where we really look through that, okay? And then for the second example, right, that was an awful two. We have essentially, right, we can definitely see that here in the y, these forces are equal, right? But the ones in the x, right, there's definitely a misbalance, right? There's an x, there's definitely more to the right, the vector on the right-hand side, right? This one over here, right, definitely is larger than this vector over here, right? So when those vectors come together, we do the superposition of these vectors here. The vectors in the y direction, since they're the same size but opposite, there's not going to be a net vector, nothing to draw for those, right? Because they're essentially going to be equal and opposite. So their superposition, or a vector that describes them both together, is essentially a non-existent vector. But in the x direction, we have a huge vector in one direction and a small vector in the opposite direction of that. So what's going to happen is when we combine those, that small vector is going to kind of take away from some of the length of this vector over here. So this vector will kind of take away some of the length from over here, which is what we see in this picture, but there's still going to be some of that larger vector left over because it's so large, right? When we do the superposition, we bring them together, right? So there's going to be some of this vector left over for the second picture. Okay, now if that's not making sense, let's just talk about it one more time, right? But like kind of maybe we can show some numbers, right? So maybe like I have this box, right? And let's say like all the forces are equal. And so, and let's give them numbers here. So we'll call this F1 and call that 1 Newton, call this F2, call that 1 Newton. Well, you might say, let's use a little bit better number. F1, we'll call that 2 Newtons. You'll see why. F2, 2 Newtons, and then we'll call this F3, and then we'll do this 1 Newton, because those are smaller. It would have been weird to kind of do something. Anyway, that's not what this video is about it. But, okay, so we can see these numbers here, right? So we know that if I do essentially the superposition, or I try to put these two, it's not drawn very well. If I try to put these two, just the y direction, this is the one in the up and down position together, right? They're in opposite direction. I know we don't have signs here, but why would they add? If they're in opposite direction, I shouldn't end up with a vector that's 2 Newtons, right? F3 is 1 Newton, F4 is 1 Newton, so they come together. It shouldn't be 2 Newtons. They were in the same direction, it would be, right? That would be the superposition of those vectors. But since they're equal and opposite, the superposition is non-existent, right? So if we go to draw the net vector for the y direction, it doesn't exist. Like we just don't draw anything, right? And then we look at the x direction, right? Well, the x direction, again, it's the same situation. The vectors are equal but opposite. So again, they wouldn't, if they were in the same direction, they would add. That would make sense, and the net vector would be twice as large, right? But as those two, or the superposition vector, however you want to think about it. But here, since they're equal and opposite, they're going to cancel. So over here, right, essentially, if you're not understanding, right, I have F3 minus F4, right? That's going to equal 0 because 1 Newton minus 1 Newton is 0, right? That was for the y direction. And then for the x direction, right, I have F1 minus F2, which we know is going to equal 0. We know it's not good. That number is going to be non-existent. But again, we'll put in the numbers. We see that's equal to 0, right? So there's no net vector here, so we wouldn't draw one. Even mathematically, we can see it, right? Versus if we have a box, and it does. It has an overwhelming larger vector in one direction versus another. Well, then we need to account for that, right? Let's give some numbers here. So this would be F1. Let's call that 10 Newtons. This would be F2. Let's call it 2 Newtons. Okay. And then we'll say F3 is still 1 Newton. And F4 is still 1 Newton. Okay. So the same thing here, right? If we did F3 minus F4, they're opposite, right? The y's. That's going to be equal to 0. Right? We know that they're going to cancel out, or, we see it with the numbers, right? I should probably put the numbers in first and then draw the second. And then And then what we see in the x direction is that, right, we have this F1 minus F2 situation, and that's going to be equal to a number, right? And so when we look at that, we put in the numbers 10 newtons minus 2 newtons, and we see that that's equal to 8 newtons, right? So it's a value, it's a number, right? And that's going to be the superposition value vector of those two vectors, right? We combined them and we ended up with this value, right? So if I were to draw this, again, the y direction, it's 0, so I don't draw a net vector. But the x direction, right, has a net vector in this direction, right? That would be the more representative of what it is. That would be the 8 newtons that we calculated here. Now, it's not always 8 newtons, right? That's just showing you an example of a superposition, right? So that's how superposition works. That's how net vectors work in terms of like netting force, or really like if you have to net two accelerations, anything, right? When you're bringing, when you got to net values together, all the, all the torques together, all the accelerations together, all the velocity together, like you're using superposition of vectors. If they're all applied to like one object, right? They're applied to different objects. You can't use superposition of vectors, okay? It's just all the forces on one object, okay? I think that makes sense. I just wanted to make a video to make sure that this is clear for everyone, but I don't want it to be long. So hopefully you enjoyed it. Again, keep in mind, I am super proud of you. If there is anything you need, make sure you reach out to your professor or a tutor or anyone who's there to provide help for you. And super proud of you, and I'll see you on the next video.